we are going to look at the details about the sound. So in our previous lectures we have studied something about the types of waves, what is a wave and the types of waves. So sound comes under the very first point you can note down here is sound is a longitudinal wave. And the second point you need to note down is sound is produced out of excitation or by means of human vocal cords or by means of some disturbance, and which is transmitted through the medium. And here sound is a form of energy, so I can write in short, it is a form of energy which gives us sense of hearing. So in simple, this is the general meaning of sound. Sound is nothing but a form of energy by means of which we are able to hear. Sound can be produced by means of, you can have so many things. One is human vocal cords. So when I use energy, then human vocal cords are getting rubbed off, producing the sound that is coming out of the mouth and traveling through the air and reaching to the listener, so that there can be a sense of hearing. And you can produce out of guitar string by playing guitar string can also produce the sound. And you can also have vibration of tuning fork by means of vibration of tuning fork, etc. So there are so many methods of producing sound. How this sound travels, what does it mean by a longitudinal wave? So as I have mentioned here, sound is a longitudinal wave. What does it mean by a longitudinal wave? The definition of longitudinal wave we require here. So we are going to look at what does it mean by a longitudinal wave. See, whenever the wave is traveling from one point to the other point, for example, a disturbance is created over here, then the wave is propagating in this direction. If the particles also propagate, particles also move in the same direction, then you call it as longitudinal. That means we can define the longitudinal wave is propagation of the wave, and the motion of particles of medium here, motion of particles of the medium are parallel. So this is an important point to note down here. So the parallel, if the particles move parallel to the propagation. So this is the propagation of the wave. This is what I am calling as propagation. This is the particle motion. So particles are moving along the direction of propagation. Such case we call it as a longitudinal wave. Sound waves are longitudinal in nature. That means how this longitudinal methodology takes place, how this longitudinal motion is going to be pictorially. To look at that, longitudinal propagation, longitudinal wave by means of a tuning fork. So let us say here there is a tuning fork and this tuning fork is vibrated, let us suppose. So when it is vibrated, then what happens? The prongs, these are called as the prongs. A and B are the prongs. When it is set in vibration, so whenever you hit with a hammer, then it is going to vibrate. When it is vibrating, it is moving to and fro with respect to the mean position. That means the position of the B is going to be like this. So outward, then inward. So it is vibrating by means of the mean position over here, outward and inward. Whenever it moves outward, the air particles near prong Air particles near the prong are getting close together. That means the particles here are narrowed because it exerts a pressure on that. Therefore, these are getting narrowed. These are getting narrowed over here. So the particles are close. Now, whenever the prong is going back, then these are widespread. So these are widespread like this. So there will be a lot of separation between the particles here, whereas there is a small separation when the particles are in this condition. And this one are named as, when the particles are nearer, it is called as compression, and when they are farther apart, it is called as rarefaction. So C stands for compression, and R stands for rarefaction. So one thing you need to remember here, whenever a sound is produced or a longitudinal wave is produced, it will travel away from the generation point. It is moving away from the generation point in the form of compressions and rarefactions. So longitudinal wave, and in particular sound wave, travels away from the disturbance, in the form of compressions and rarefactions. Now how it is going to happen, that you can see in the pictures shown in the video below. So there are some pictures shown in the video below. You just have a look at those videos. You will be understanding how these particles are moving ahead of the tuning fork. So this tuning fork, whenever it is vibrating, the particles near this will be closed and farther apart. Likewise, these will be moving away from the tuning fork